Yeah, I've seen skiers go there. They go to.
I got it. The what? I know, well, you got
On the snowboard, I don't even know.
I know, but
I guess the longer board you have, the more. I guess the faster you can go at it. Less likely to fall. Would be terrible.
All right, so we got some homework to be done, okay? Stuff's due tomorrow. So let's have a look. You guys okay with this one? We got any questions on this?
Do we care about the direction?
Yeah, you would. You know, what we're looking at here is what those two forces do to A. You know, they'll probably influence how A is designed, however that connection's designed at A. So, yeah, you would care about the direction, you know.
So the sum of the x
Well, that'd be more equilibrium doing that. I mean, we're just looking at the effects that these forces have on A. So, yeah, they don't zero out. You know, I think when you get some of the effects, you get 3.24, and sum of Fy is negative 7.89 when you do this. So, you know, so what you do on this is that, you know, the usual kind of stuff on this. Maybe I go like Fx, Fy, and maybe we'll do it this way. There we go. And so if you've got that first force, Fb, you know, it's just the usual trig thing. So you got cosine of 40 times 7. And these units are kilonewtons, so I'll just put the units up there. And so when you run that, you'll get 5.36. And then you'll do the, you know, business here too. So this is minus sine 40 times 7. And what is that? That's minus 2.12. All right. And then you'll get FC, and then you'll add everything up. And when you do that, you ought to get 3.24 here. And minus 7.89 over here. Okay, and then once you've got that, what you would do next here would be to, you know, just go through this process here of finding the total resultant. And that's sum of Fx squared plus sum of Fy squared. Take a square root, so that'll get you the resultants. And that comes out to be 8.53. And then to get theta, what you do, you take arctan, which is also tan to the minus 1, and that would just be negative 7.89 over 3.24, and that would get you theta, and that comes out to be negative 67.7 degrees.
Is it always going to be the sum of the y over the sum of the x for the arctan?
Yes. Yeah, it's by definition, because the y is the opposite and x is adjacent, so yeah, it's always that way. Okay. So you're just going through this, you know, sort of deal here. Do the trigonometry, break them up into x's and y's, add up the x's and add up the y's. Square root of sum of the squares is the magnitude of resultant, and the arctan of y over x is the angle. And then, you know, you do the sum of moments too, if you like. So sum of moments about A, I think we need that. And the only thing that's going to enter into this would be the y components there, right? So that'd be minus sine 40 times 7 kilonewtons times its moment arm, which is 3 meters. And that's going to be minus because it's clockwise. So when you add up all the moments, you got another term to put in there. What you get is negative 27.1 kilonewton meters. Okay. And then the last part of this is to come up with the distance that resultant force would be from A in order to cause the moment. So kind of what we got here, we've got this sketch. And what we found is that we have a net force of 8.53. And what we want to know here is how far would that be placed from A? So what's this distance here? Such that it would cause the moment of negative 27.1 kilonewton meters. So when you run those numbers, what you ought to come up with is 3.43 meters is what that distance should be. Any questions on that one? Coming up with that.
And did you do that again for the other 4 kilonewtons?
4 kilonewtons. No, the 8.53 is the total. So what we're doing is finding the location where we could put the resultant so that it'll cause that moment that we got, the clockwise 27.1. So and the way we're doing that is we're just using m equals force times distance and backing into the distance. Because you know what the resultant force is, you know what the moment needs to be, so you can solve for the distance. Any questions on that bit? Okay. So there's the basic process of coming up with a resultant. Okay. Use trig, get x's and y's, add up the x's, add up the y's. Theorem of Pythagoras gets you the resultant magnitude, and arctan of y over x gets you the angle. You can also sum up moments about a point as well. Okay. All right, now that holds for this one here as well. We got a couple thrown into this one that you have to consider. So there's a few things going on with this. All right, so what you want to do with this thing is just start to do the same process. So you want to add up the forces in the x and just see what they come out to be. So you've got a 60-degree angle in there, for instance, so that'll be minus because it's to the left, cosine 60 times 900 newtons. And you're going to have another one in there, and when you're all done, it's negative 1513 newtons. And then you'll go sum of Fy, and you'll have two terms in that one. 1, 2, and that will come out to be 1064 newtons. So then the resultant will be based on square root of sum of the squares. and that comes out to be 1850. And then you can find the angle as well. So the angle will be based on doing the arctan stuff, okay? Now watch the direction on this one, okay, on the angle. It's 35.1 degrees, but watch which way it points. I don't know if I put that in the solution or no, but okay, what your calculator is going to tell you is it's negative 35.1, but see, it's not pointing that way, it's pointing up the other way. So you want to have it up that way, okay? Questions on that so far? All right, and we're good on that. You also need to find the moment. Okay, so the moment there, what we've got for the moments is sum of moments equals, and then, off you go with that. You're going to have sine 60 for that force at B times 900 newtons times the moment arm of 2.4 meters. That's going counterclockwise, so you can use a positive with that. You're going to have three other terms. Looks like they're all positive, aren't they? Yeah. Okay, and when you add them all up, what you're going to get is 4529 Newton meters. Now what you've got there is a couple acting on this thing. There's a motor there at A that introduces a couple. So just add the couple in, okay? You don't need a moment arm or anything like that. Just add it in. That's what you do with couples. So it's just another term. Just put it on in there and include it when you go through. Got any questions on it? All right. Okay. And then we get into the problems with distributed loads after that. So this one here is kind of a two-part question. The first question is just to find the force and moment about A that's caused by that loading. Okay. So what you're going to want to do there is take that and break it into two pieces. You want a triangle and a rectangle. All right. And then you just put the centroids on there and put the loads at the centroids of the figures. Now what you want to see here is this one's going to be 30 for the height. This will be the remainder between 30 and 78, so that's 48. Okay, so those are the values that you want there for the triangle and the rectangle. So this is kilonewtons per meter. As is this. Okay. So we okay with that?